Hello, this is Ms. DB, and in this lesson we're going to go over Chapter 5, Section 5, which is on indirect proof, and then also inequalities in one triangle. It's kind of like two separate topics, but in order to prove the theorems in this section, you have to use indirect proof, so then we kind of have to go over what that is. So we are going to write indirect proofs and also apply inequalities in one triangle. Our vocab is just indirect proof. All right, so far, all the proofs that we wrote have used direct reasoning, which means that we start with a true hypothesis and then we build our logical arguments using given and theorems and definitions in order to show that the conclusion is true. But in an indirect proof, the first step that we do is assume that the conclusion is false. And then you show that this assumption leads to a contradiction, something that's impossible, something that cannot be equal or cannot be true. This type of proof is also called a proof by contradiction. So let's see how the steps are going to go. First, we're going to figure out what is the conjecture to be proven. Sometimes it'll just say, prove this. Sometimes you'll have to kind of work that out. Then the second step is to assume that the opposite of the conclusion is true. So if it is said that something's equal to something, the assumption would be that it's not equal to something. If it's something is greater than, we'll assume it's less than. So the opposite. Then we'll use direct reasoning, the stuff we've already done using givens and theorems and postulates and definitions in order to try to prove that assumption true, but it won't work. What we'll get is a contradiction. We'll get a false statement. We'll get something that cannot be true. And then, since the assumption is false, the original conjecture must be true. It's kind of a fun way to write a proof. Let's look at how it's going to work. All right, so write an indirect proof that if a is greater than 0, then 1 over a is also greater than 0. So let's first think about this. A is any number, so it has to be greater than 0. So let's say 4. If 4 is greater than 0, then 1/4 is also greater than 0. So it makes sense with examples. So I can put in specific examples, specific instances, and it seems to make sense. If a was a really big number, like 100, then 1 over 100 would also be greater than 0. Okay, so the conjecture to be proven is not that a is greater than 0, that's our given, but that 1 over a is greater than 0. Okay, the opposite of this would be what? What's the opposite of 1 over a is greater than 0? It would be 1 over a is less than 0, or could be equal. Okay, that's the opposite. All right, next we're going to try to write a proof to prove that 1 over a is less than or equal to 0. Now you can do it with a two-column proof. In the book, they'll often just kind of use paragraph proofs. They'll just kind of explain. So here's our first one. We're starting with our given that a is greater than 0 and also our assumption. 1 over a is less than or equal to 0. That's our assumption. Then we're going to use a property from earlier on this year that said that you can multiply, what is the zero property of multiplication, property of equality? That you could take 1 over a and you could multiply, they're not showing it, but you could multiply both sides by a, and what you would get would be 1 is less than or equal to 0. 0 because 0 times anything is 0, so that gives you 0. 1 is less than or equal to 0. Wait a minute, 1 is less than or equal to 0? That is false. That is a contradiction. That is not true. 1 is greater than 0, not less than. So therefore, our original conjecture is true because our assumption was false. So our original conjecture is true. That's an example of an indirect proof. So that means that 1 over a is greater than 0. Okay, let's look at this one. This is more like a geometry kind of thing. Write an indirect proof that a triangle cannot have two right angles. So the conjecture is that a triangle cannot have two right angles. Now, for our given, we had to use something we already knew. I already know that all the angles in a triangle should add up to 180 degrees. We learned that already. That was the triangle sum theorem. So that's our first step, to figure out what's given and what's the opposite of the conclusion. Then we want to assume the opposite. What's the opposite of a triangle cannot have two right angles? It's an angle does have two right angles. That would be crazy, huh? Now we're going to try to prove that. Let's see. We'll start with the triangle sum theorem. Now let's say that it does have two right angles. That means that two of them, and it didn't matter which two you plugged in, would be 90. But that, if we subtract 180 from both sides, we would get the measure of angle 3 was 0 degrees. How can you have a triangle with an angle measure of 0? You can't. We learned way back, like in section 1.1, that the measure of an angle is greater than 0. It's between 0 and 180. So we can't have an angle with a measure of 0. It's impossible. It's a contradiction. So if that's false, it means that our original statement is true, which is that a triangle cannot have two right angles. So we proved that that was true by indirect proof. Okay, the rest of this section is much easier. It's the positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. Let's look at a picture. That means that if we have a side AB that we know is longer than side BC, it's also going to be true that the measure of the angle opposite that long side is going to be greater than the angle opposite the short side. And that kind of makes sense, right? If you have a longer side, the angle opposite will be greater than the angle opposite of a small side. The opposite is also true if you have an angle that's big, then the side opposite will be longer than the angle that is smaller. So it works both ways. So here's what we're going to do. We're going to write these in order from smallest to largest. Let's write the side lengths first. Which is our smallest side? GH. This is the smallest. Which is the largest? This is the largest. And I'm going to put medium here. Medium. Middle? I don't know. Now, the smallest angle will be opposite the smallest side. The largest angle will be opposite the largest side. So this is the largest angle. This is the smallest angle. And this must be the mediumest angle. Mediumest? So the smallest angle, remember where that was, is opposite the smallest side. That's angle F. So angle F is the smallest. And then the next one would be angle H. And then the last one would be angle G. So angle F, angle H, and angle G is in order from smallest to greatest. Okay, now in this one they give you the angles and you have to find the sides that match. First of all, what is this side? We know that all together, all of these angles have to add together to get 180 degrees. So we got to find that first. So our first step is to figure out what is the missing angle. It's 48. Okay, that's important. 48 degrees. So if it's 48 degrees, then the smallest angle is that one. It's angle R. That means that the side opposite it is going to be the smallest side. What's next? 60 or 72? This one's next. So that's going to be the medium side, and then this will be the largest side. So written in order, we are going to write P, let's see, the smallest one is PQ. So you have to write it like that. You have to write PQ with 2 capital letters. And since on your typewriter or your keyboard you don't have, it's hard to underline at the top, or not underline, but it's hard to put that segment symbol there. So you might just write side PQ, and then the next one would be side QR, and then the biggest one was side PR. If you're writing it by hand, then you can put them this way, PQ, QR, and PR. So those aren't bad at all. Here's another example of doing the angles. So opposite the smallest side is the smallest angle, and that is angle B. The biggest one is opposite the longest side, so that's angle C, and then the medium one would be angle A. And then this one says to write the sides in order. Now, they only give us one angle, but this is a right angle, so this is automatically 90 degrees. And then we can take 90 plus 22 plus measure of angle E to get 180. And we'll find that the missing angle measure is 68. So the smallest one is opposite the 22-degree angle, opposite angle D, so that's side EF. Opposite the biggest one would be side ED or DE, and then the mediumest one is DF. That's opposite the angle that was in the middle. Okay, a triangle is formed by 3 segments. We already know that. But not every set of 3 segments can form a triangle. Your journal for this week is going to go over this idea, so make sure you've done the journal. This first example, I'll call this A, has lengths of 7, 4, and 4, and you can actually cut these lengths out with the paper, or you can cut straws, or I don't know, anything, toothpicks maybe, 4 centimeters, anything you can find to make 4, 4, and 7, and you can actually build this triangle. But if you try it with slips of paper that are 3, 3, and 7, it doesn't work, because let's make this be 7 units long. 1, 2, 3, 4, 5, 6, 7. Here's 3, 1, 2, 3, and I'm going to do 3 from this end. 1, 2, 3. There's a gap in the middle. If you folded this piece down and this piece down, they wouldn't even touch each other. And even if it was 3.5 and 3.5, they would touch each other in the middle, but you wouldn't be able to make a triangle. They would just fold up. So there's a statement about this, a theorem, that says that the sum of any 2 side lengths of a triangle is greater than the 3rd side length. If it doesn't meet this, then it's not going to be a triangle. It wouldn't be possible. So every 2 sides, I'm going to call this side 1, 2, and 3. So side 1 plus side 2 has to be greater than side 3. Has to be true. Also, side 2 plus side 3 has to be greater than side 1. And then which one? I didn't do 1 plus 3. 1 plus 3 has to be greater than side 2. If that's not true for every single pair, every single statement, then you will not be able to make a triangle with those lengths. And that's what you'll be doing, is you'll just be checking. So the way you do it is you do exactly what I just did. You do it 3 times. And if all 3 of them are true, then it'll work. So on your paper, you would write 7 plus 10 is that greater than 19? And you'll check and see, well, that's 17 is greater than 19. No, it's already failed. So this is not going to be able to be a triangle. It would work on maybe some of the other ways, but if it fails for one, it's done. You don't have to check the other ones. Let me just check some of the other ones. 7 plus 19 is greater than 10, yes. 19 plus 10 is greater than 7, yes. But because it failed here, you would just say, no, it cannot have these side lengths. This would not be a triangle. Okay, let's check this one. Remember, we're going to check it all 3 ways. Unless you find a fail, then you're done. Is 2.3 plus 3.1 greater than 4.6? Is that true? Yeah, it'd be 5.4 is greater than 4.6. That one's good. Now let's check the next combination. 2.3 plus 4.6 is greater than 3.1. Yep. Okay, and we have one more to check. 3.1 plus 4.6 is greater than 2.3. That one checks. So that means that this is a triangle. It could form a triangle. So you'd say, yes, it meets the triangle, what was this called? Triangle inequality theorem. Sorry, it's right at the top of the paper there. Now, sometimes you will have to plug in first to check. So this time they're giving you that n is equal to 4, and then they give you this is one side, this is another side, this is our third side. So I'll just take the 4 and put it here, and then I'll take the 4 and I'll put it here and square it, and then minus 1, and then I'll take the 4 and put it here. And then I'll do the same thing. So first we have to find out we have to evaluate and find out what our sides are. So we get 10, 15, and 12. And then, once you know this, then we'll do our checking. 10 plus 15, is that greater than 12? Yes. 10 plus 12, is that greater than 15? Yeah, that'd be 22. That's good. And then the last one would be 12 plus 15. Is that greater than, what's our other side? 10. Yeah. So it works in every case. So then we would say, yes, this is a triangle. It could be a triangle. Okay, here, this one is just another example, 8, 13, and 21. It fails right away, though. 8 plus 13 is 21. 21 is not greater than 21. So you might get tricked here, but it would not make a triangle because 21 is not greater than 21. And then you're done after that. Try this one. It works on the first example, works for that one, works for that one. So we would say, yes, this could be a triangle. And then in this one, we're going to plug in when t equals 4. So the first step on these is to figure out what are my lengths of my sides by evaluating. And then we can check. 18 is greater than 17. 19 is greater than 16. 33 is definitely greater than 2. So this one could have worked. Could be a triangle. In this example, you're going to find a range. It says that two sides of a triangle are 8 and 13. So let's say this is 8 and this is 13. We want to know what could that third side be. So here's how you're going to do this. We're going to let this side be x. We don't know what that is. And we're going to set it up like we were doing before. We know that we have to take x plus 8 has to be greater than 13. And x plus 13 has to be greater than 8. And we have one more to do. 8 plus 13 has to be greater than x. So then we simplify. On this first one, I'd subtract 8, and I'd get x is greater than 5. On this one, I'd subtract 13, and I get x is greater than negative 5. And on this one here, I'd get 21 is greater than x. Now let's think about these two things. X has to be greater than 5, and x has to be greater than negative 5. Well, if you're on a number line, here's negative 5, here's 5. If x is greater than 5, it doesn't matter if it's greater than negative 5. The x is greater than 5 covers that. So we don't need this part because it's taken care of by the x is greater than 5. Another way of saying this is that x is less than 21. So x has to be greater than 5, and x also has to be less than 21. Now we're going to put that together. Here's how you put it together. You can either write x is greater than 5 and x is, you can just leave it like that if you want. Or you could write it as one thing saying that 5 is less than x. That makes sense, right? X is greater than 5, 5 is less than x. And then you can combine it into one inequality by putting the x is less than 21 over here. So this is combining this step here of x is greater than 5 and x is less than 21 into one inequality. But if you have trouble doing that, you can leave it as this step right here. You could even use words. You could write x is greater than 5 and less than 21. Okay, here's another example. The lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possibilities for the other side. So 17, 22, and I don't know this side. I'm going to call it x. So we're going to write our three different statements. X plus 22 has to be greater than 17, and then by that one you subtract 22 from both sides. So that means that x is greater than negative 5. Also, x plus 17 is greater than 22. I don't know why 5 came up twice here. And then the last one would be 39 is greater than x. Now here again, if x is greater than 5 and x is also greater than negative 5, if both of those things have to be true, this is the only part we need because that takes care of both of them. So if we put that together in one statement, it would look similar to the last one. X has to be greater than 5 and less than 39. This is just a travel. You're just going to be using what you already know. and it says, what is the range of distances from San Francisco to Oakland? It's just doing the same thing we just did, and you would write the 3 different statements and then try to write a combined inequality. So we get that, what the heck is with the 5s? It is not always 5 and -5, I'll promise you. I don't know why all 3 examples I've done have been that, but. So again, we need the x is greater than 5, and the 97 is greater than x, or x is less than 97, and then we can combine it, if you want, into 5 is less than x is less than 97. In other words, x is between 5 and 97. That's our range. Can't be 5, can't be 97, but it can be between those 2 numbers. All right, that's it for today. I hope you understood. If you have any questions, please let me know or come to my office hours. Thank you very much.